right, looking at 4.1, function operations, and we are on task 3. All right, so it says let f of x equal 3x squared and g of x equal 4x minus 5. Find f times g and g divided by f. Simplify your results. All right, so the first thing it's going to do is going to show us that we're going to do multiplication. So f times g of x is the same thing, or another way to write f of x times g of x. All right, so all we're doing is taking the two functions that they gave us above, right here, 3x squared and 4x minus 5, and we're going to multiply those together. So since this is a binomial, we have to distribute. So you're going to have 3x squared times 4x, which gives us 12x cubed. And then 3x squared times 5 is negative 15x squared. All right, so A part says, how can you justify the values of the exponents of x in the last step? All right, so this goes back to properties of exponents. So x squared times x, same base, you add exponents. So it's not the identity property. By the product property of exponents, it's not the product property of exponents. I mean, it's the product property of exponents, but you don't multiply the exponent powers. The product property of exponents, if you have the same base, you add the exponents to find the exponent power. So the last answer there is the correct one. So that's just properties of exponents, which you did last year in Math 2. All right, so this says g of f. This is kind of hard to read because the way it's typed here, but g of f of x equals g of x divided by f of x. All right, so they put g of x on top, 4x minus 5, divided by 3x squared. Are there any values of x for g divided by f undefined? Well, remember we talked about anything that would make the denominator 0, because division is undefined if the denominator can equal 0. So negative 1 wouldn't matter. 0 squared is 0, times 3 is 0. So 0 would make the denominator undefined. 1 squared would be 1, times 3 is 3, that wouldn't matter, and 5/4 wouldn't matter for the same reason. So the only one that would be a restriction is the 0. All right, so that's task 3. We're going to move on to task 4, so if you have any questions, let me know. All right, task 4, model with function operations. Renardo self-published a travel book. His revenue R in dollars from selling X books is modeled by R of X equals 15X. The function C of X is 6X plus $7,250 models the cost to print X copies of the book. Write a function that models Renardo's profit P from selling X books. What is his profit from printing and selling 3,500 books? Remember that profit is the difference of revenue and cost. So Renardo's profit is modeled by the function P of X equals R minus C of X, so revenue minus cost. P of X equals R minus C of X, and so that would be 15X minus 6X plus 7,250. So that's from the R of X and the C of X given above. So if we simplify that, that is 9X minus $7,250. All right. What does it mean if the value of P of X is negative? All right, so if revenue minus the cost is negative, that means he spent more money printing the books than he made. So that means he has a loss. Renardo spent blank money printing. It means he spent more money printing the books than he earned from the sales. So that's if it is negative. Okay, so it says for the expression 15x minus 6x plus 7,250 to give the true profit, what must be true about x in R of x and C of x? So it says none of the books printed will be sold. The value of the function must be negative. All of the books printed must be sold. The value of the function would have to equal $0. So for the expression to give the true profit, all right, to give the true profit, you have to sell all of the books and minus the cost from that. So to find the true profit, you want to sell all of the books. All right, explain your reasoning about the profit. Okay, if more books are printed than are actually sold, the profit will be reduced by the cost of printed of unsold books. All right, so anytime you don't sell everything, then that's going to be a reduction in cost. So you can kind of see, like from the formula above, it looks like that the cost, 6x plus $7,250. It looks like the $7,250 is probably the initial cost. So that's probably like the setup fee for the printers, getting it edited and all of that stuff and ready to print. And then it cost an additional $6 times every book that was printed. If you wanted to find out how much your true profit would be, you could take the 3,500 books that they printed and you could plug it into this function here. And this is revenue minus cost. So the true profit from this transaction would come if you substituted the 3,500 in for 9x. All right, that's all for task 4. If you have any questions, let me know. All right, task 5. A coffee shop chain is growing both in its number of locations and its revenue per location. The projected number of shops, F, and the annual revenue, R, per shop in thousands of dollars, X years from now are shown in the image. Find a function that models the total projected annual revenue for the chain X years from now. What is the total projected revenue 4 years from now? All right, so this is locations. Your f of x is 3x plus 18, and the revenue, r of x, is 8x plus 350. So locations, f of x, revenue, r of x. So it says total revenue, T, from all the shops is the product of the number of shops times the revenue per shop, or the product of r of x and f of x. All right, so if we take the r of x and the f of x from the image here, so we've got 3x plus 18 and 8x plus 350. The order doesn't matter, but they've multiplied these together and got this expression here. All right, so this is our t of x. It says, how can you verify that the function expression gives the correct units? So the expression 3x plus 18 describes what? So 3x plus 18 describes the number of locations. All right, because it said from above, this is your locations here. And then the other one is your revenue. So the expression here is the revenue in thousands of dollars. All right, it says, so multiply these expressions gives the number of stores times thousands of dollars equals, or per store, thousands of dollars per store equals thousands of dollars. All right, so if you multiply the two expressions given, you've got stores and thousands of dollars. So this is just going by what the information has up here. So if you look up here above, it says that it's in thousands of dollars. So they're referring back to that original statement at the top. And then does it seem reasonable? What does it seem reasonable that multiple coffee chains times their revenue is going to generate thousands of dollars? And I would think, yes, that does sound accurate. So that's it for task 5. If you have any questions, let me know.